All right, we are on lesson 5. This is page 387. The learning objective for lesson 5 is I can compare and order rational numbers. Now, before this lesson starts, I am going to show you what stuff I did in high school. So I was in winter guard. That's when you twirl a flag, but it's like inside, not outside. And I was also in marching band and concert band. Wow. Let's see. Oh no, this isn't the one that I was thinking. That was my brother. And I was in dance. Wow. Tap dance. And I was in musicals. So this was Guys and Dolls. And oh, there was one more thing I wanted to show you in high school. I was good at math. Wow, we actually posed with our calculators. Interesting, huh? Yeah. Okay, on to math. Speaking of calculators, oh wait, never mind. No calculators needed. So, comparing and ordering rational numbers, that's what we're going to do. Earlier in this chapter, we compared and ordered integers, right? Negative and positive whole numbers. Now we're adding in fractions and decimals too, negative and positive. And we're going to compare to and then order like sets of numbers. Okay, here's the real world link. It says, insects. The length of several common types of insects are shown on this table. Which insect is the longest? So look, these are all fractions, 3/4. Oh wait, 1/1 equals 1 whole. This is fraction, fraction, fraction. So all of these are fractions. This is actually 1 whole inch. Everything else is less than an inch because it's a fraction of an inch. So the longest one is the cricket. Now shade each fraction strip to represent the lengths of a fire ant and a housefly. The fire ant is 1/3 of an inch. The housefly is 1/4 of an inch. So which one is longer? The fire ant is longer. How many insects are longer than 0.5 inches? Now remember, 5/10, when you divide by 5 and simplify that, is 1/2. So what is less than a half? Or no, I'm sorry, longer than a half. Well, we know the cricket's longer than a half because that's a whole inch. What about 3/4? 3/4 would be, this is a half, right? So 3/4 is greater, so this one is greater. And 1/3, look at, that's not, this is 1/2. So that's less than a half. That one doesn't work. 3/4 again, that works. 1/4 is just this, that's not quite a half. What about a half? That's not greater, that's equal to. And 5/8. Now think about 5/8. Each of these is 2/8. So 1, 2, 3, 4, 5, 6, 7, 8. 5/8 would be this much. So that's greater than a half. So 4 insects are greater than a half an inch. Order the lengths of a housefly, a green June beetle, and a fire ant from shortest to longest. So the housefly is 1/4 of an inch. The green June beetle is 3/4 of an inch. And the fire ant is 1/3 of an inch. Now you remember to compare these fractions, you need to have the common denominator. So we need to find the least common denominator. So multiples of, well, 3, 6, 9, 12. 4 times 3 is 12. 3 times 4 is 12. We could turn all these into twelfths. So 1/4, 3/4, and 1/3. If we turn all these into twelfths, then we can compare the numerators. So 4 times 3 is 12. 1 times 3 is 3. 4 times 3 is 12. 3 times 3 is 9. 3 times 4 is 12. 1 times 4 is 4. So what is it? Shortest, 3/12, then 4/12, then 9/12. So the one that was 3/12 was 1/4. The one that was 4/12 was 1/3. And the one that was 9/12 was 3/4. So this is just a reminder about least common denominator. It's something that we're going to have to work to do in this lesson. All right, in the lesson, we're comparing decimals and fractions on the left. And then, so we're just talking decimals and fractions. Then we're going to talk rational numbers. Both sides are dealing with negative and positive numbers. So on the left it says, positive and negative rational numbers can be represented on a number line. You can use a number line to help you compare and order rational numbers. Now I've got some tips for you about this. Let's remember, first, when you're looking at positive and negative numbers, the positive is always greater. So that's tip number 1. Let's remember that over here on the left. So tips. 1. First, check positive versus negative. Positive is greater than negative. So a positive number is greater than a negative number. Now, if both are positive and both are negative, what do? So, we know what to do when it's whole numbers. We just talked about what to do with fractions. So with fractions, you find the least common denominator. So let's talk about this. 2. If both numbers are positive or negative, then with fractions, you need to find the least common denominator and compare numerators. What do you do with decimals? So if you have 2 decimals, you can look and compare place value. So you can compare place value from left to right. So I'm going to say look at place value from left to right. So these are the tips that we're going to refer back to when we aren't quite sure what to do. All right, fill in each circle with less than, greater than, or equal to make a true statement. Now look at this. We can go on tip number 1. Positive's greater than negative. So this negative number has to be less than the positive number. And if you graph it out, if you look at their graph, this is negative 1.2, this is 0.8, and you can see 0.8 is greater. Okay, now both of these numbers are negative. So both numbers are negative, and we're talking about decimals. So we're going to look at place value from left to right. So they're both 1s and they're both 4s. Now since they're negative, the 4 would make that one less than the 2. Look over here on the number line. This would be negative 1.4. This is negative 1.25. So see how this is less than negative 1.25. All right, let's look at example 3. This is going to be where we look at least common denominator because we have 2 fractions and they're both negative. Remember to find the least common denominator, you have to find the least common multiple of the 2 numbers. So 8 and 16 here, 8ths and 16ths, their multiples, 8, 16, 24, 16, 30. The least common multiple is 16. So if we can turn 3/8 into 16ths, we already have 5/16 and 16ths, then we can compare the numerators. So negative 3/8, when you multiply the numerator and denominator by 2, you turn it into sixteenths. So it's negative 6/16. The other one was negative 5/16. And since we're talking about negative numbers, negative 6 is to the left. So it's less than negative 5/16. So this is like negative 6/16 is less than negative 5/16. So again, the tips are look for negative. Negative is always less than positive. When they're both negative or both positive, for decimals, you look at place value. And for fractions, you find the least common denominator. So we're going to do these ones to practice. First, this is positive, this is negative. So we know the positive is greater. These are both negative, these are both negative, these are both positive. So this is decimals. We're going to look at place value. 4s are the same, 5s. So this is bigger. However, they're negative. So this is going to be less than this. What about this? We both fractions have 16 in the denominator. So we can look at the numerators. 12 is greater than 9. These fractions are both negative. Look at the denominators though. They're not the same. We could turn 5 into tenths. If we multiply by 2, we have to do the same to the numerator. This is going to be 10. This is going to be 8. Now we're talking negative numbers. So 8 tenths, negative 8 tenths is going to be below negative 7 tenths on a number line. So this is less than this. So we have to really use our brain on this, depending on if it's negative or positive. We've got to think back to what we learned at the beginning of this chapter and really connect everything we learned. Okay, moving on to page 389. Compare and order rational numbers. To compare and order rational numbers, first write them in the same form. Now, we did this back in chapter 2 or something like that when we were comparing fractions, decimals, and percents. And what we said was if you have a mix, always get them all as decimals to compare. So when you're comparing and ordering rational numbers, here's our tip. What's the word for turn? Convert all rational numbers in a mix. So if you have a mix of rational numbers, turn them all to decimals. If you turn them all to decimals, that's the easiest way to compare. That's what we've always done this whole year. There's going to be one more tip. If you're dividing, so when you have a fraction and you have to turn a fraction into a decimal and you do 8 divided by 15, when you're dividing, you might not need to divide all the way just to find a comparable number for your place value. So we're going to refer back to this later. When dividing numerator divided by denominator, you may not have to divide all the way. Okay. If this is confusing to you right now, don't worry, because it's going to make more sense when we're actually doing it. So we'll refer back to these tips. It says fill in each circle with less than, greater than, or equal to make a true statement. So we have two rational numbers. They're both negative. One's a decimal, one's a fraction. And our tip was, when you have a mix, turn them both to decimals. So we already have this as a decimal. We need to turn this into a decimal too. So it says rename negative 8/15 as a decimal. So negative 8/15, to turn that into a decimal, you do 8 divided by 15. Remember that from the last lesson? 15 can't go into 8, so there you go. Now, 15 can go into 80. 2 15s is 30, so that would mean 4 15s is 60. So 5 15s would be 75. And I'm going to annex and bring down another 0. So 2 15s is 30. 3 15s would be 45. And see, look at we have 0, and then remember this is negative 0.53. I don't really have to keep going all the way because now I have something to compare to. This place value right here in the hundredths place is what I'm comparing. So I have negative 0.53 repeating, negative 0.51. This number is greater than this number here. So I put in my symbol. All right, so remember, the number to the right on the number line is always greater. That's what this is saying. Okay, now we have a mix. We've got a set of numbers. They're mixed. We have decimals and fractions. We need to turn them all to decimals. That's our tip up here. Turn all rational numbers to decimals when they're mixed. We have to order from least to greatest. So it says we need to turn negative 2 and 22/25 and negative 2 and 1/10 into decimals because they're all negative too. So negative 2 and 22/25, they turn into decimals for us. But let's go over here and see how you do that. So negative 2 and 22/25, that's what? So 50 plus 22 would be 72. So that'd be negative 72/25. So then you'd have to divide 72 divided by 25, right? Make it negative. So 25 goes into 72 twice. That's 22. Now look, we're going to have to do this and bring down a 0. Okay, so 25 goes into 104 times. It would go into 208 times. Bring down another 0. It's 200 again, so this is going to be repeating. So here, see, this is where they got negative 2.88. Now, negative 2 and 1/10. Let's do that one. Negative 2 and 1/10 is 21, negative 21/10. So that would be 21 divided by 10. That's negative. 10 goes into 21 twice. There we go. We got to bring down that 0. It's going to go into that once. So that's where they got the negative 2.1. When you place these three numbers, negative 2.46, negative 2.88, and negative 2.1, the numbers to the right are greater than the numbers to the left. So this would be the smallest. That was the negative 2 and 22/25. This negative 2.46 is in the middle, and the greatest is the negative 2 and 1/10. So now we're going to do this here. Down at the bottom, it takes a lot of work. It's okay, you can do it. We haven't done a lot of work in this chapter yet. So we have a fraction and we have a decimal. We are going to need to turn, since they're both negative, we're going to need to turn this fraction into a decimal. So negative 3 and 5/8. What is that as an improper fraction? 3 times 8 is 24. 5, 6, 7, 28, 29. So this would be negative 29/8. So we need to do 29 divided by 8. So 8 goes into 29, 3 times, because that's 24. Now we have to do this decimal business and annex zeros. 8 goes into 50 6 times. Bring down another 0. 8 goes into 20. Did I do that right? Yeah. 8 goes into 20. Twice, right? to bring down another 0. And look at, that's perfect. 5 times. So 3.625. Oh, and it's negative. So look at, those two are equal. Wow. Okay, what about this right here? 3/7 and 413 thousandths. They're both positive. So let's turn 3/7 into a decimal. I'm going to do that right over here. So 3 divided by 7. 3 divided by 7, we need to add that decimal. 7 goes into 30 4 times. Bring down another 0. 7 goes into 20 twice. Oh, now look. I think we can stop right here, because this would make this 0.42, and look, 0.41. 42 hundredths is greater than 41 hundredths. So that's another example of this right here. You may not have to divide the whole way. All right, last one. We have all negative numbers. They're a mix of fractions and decimals. So we need to turn them all into decimals. Here we go. I'm going to just block that off right here. So -7 13/20. 7 times 20 plus 13. So 7 times 20 would be 140, plus 13 is 153/20. So now we divide. 153 divided by 20. All right, here we go. 20 can't go into 15. So how many times does 20 go into 150? 2, 4, 20, 40, 60, 80, 100, 120, 140. So 7 times. 20 times 7 is 140. We're going to start to have to bring down zeros. Oh, and this is a negative number. So 20 goes into 130. What, 6 times? So look at this. -7.6. I might not have to go any farther, because this right here is -7.6. This is -7.7. Let's see what this one's going to be. I'm going to bring that right here. 7 times 100 is 700 plus 17. So 717 hundredths. That's 717 divided by 100. 100 goes into 700 7 times. Here's our decimal. Bring down the 0. Goes into 170 once. Now, see how we can stop here? This is a negative number. This is -7.1. So now we have, thinking of a number line, if this is 0, -7.1 would be higher, greater than -7.6, which would be greater than -7.78. So we need to order from greatest to least. So it would be the -7.1, which was -7 17 hundredths. That's greatest. Then -7.6, which was -7 13/20. Then the -7.78. Wow. But when you're done, you know it's right. You feel good. So, flip to the next page. Story problem. Mr. Plum's science class is growing plants under different conditions. The table shows the difference from the average for some students' plants. Order the differences from least to greatest. Okay, so we need to order all of these from least to greatest. We need to put them in decimal form. And look at, we have some positive and some negative. So, Ricky's plant, 3 1/4, is 3.25. Now, did you know that 1/4 is 25 hundredths? So Suni's plant is 1.7. These are all positive numbers. Debbie's is negative 2.2. Lenora's negative 1 7/10, which is negative 1.7. So if you're thinking of a number line here, the biggest one, if this is 0, is Ricky's, right? 3.25. Then Suni's at 1.7. Then it would be negative 1.7 and negative 2.2. So from least to greatest, there's negative 2.2, negative 1 7/10, 1 7/10 that's positive, and 3 1/4 that's positive. Yippee! The lesson's done. It's time to partner up for guided practice. All right, guided practice time. Make sure that you have a partner. If you don't have one and you need help getting with one, let the teacher know and you can pair up. So we are going to do 1 through 7, which sounds like a lot because these have been a lot of work, but actually some of them are really fast. So the first 4, we're comparing just 2 rational numbers. Now look at this. We've got a positive number and a negative number. So which one's greater? The positive number. Okay, keep going with these first 4 and then check them with the video. Look, positive, negative. Positive's greater. Here we have 2 negatives. Look at 6.7 is 6 7/10, right? 6 7/10. So those are equal. Now let's turn this into a decimal. I don't know what 5/6 is as a decimal. So we need to do 5 divided by 6. And I'm going to need to pull that up. So 6 can go into 50. 8 times 6 times 8 is 48. Now look, negative 0.8 and negative 0.9. You don't have to keep dividing because you can already compare these two. Now on a number line, 0, negative 0.1, negative 0.2. So negative 0.8 would come be negative 0.9. All right, let's look at number 5. So we have a set of numbers, and first we can look at positive and negative numbers. So the negative numbers we have are negative 3 1/3, negative 3 3/4. And then the positive numbers that we have are 3 3/10 and 3 1/2, or 3 5/10. So let's think about this for a minute. On a number line, if this is 0, 3.3 would come before 3.5. So this is greater. Now look at this. 3 1/3. If you have a third of a candy bar, it's just that much. If you have 3/4 of a candy bar, it's almost the whole thing. So this is going to be more negative than 3 1/3. So we're supposed to order these from least to greatest. So the least would be negative 3 3/4, then negative 3 1/3, then 3 3/10, and then 3 5/10. So actually it was kind of interesting because on this one you didn't really need to turn the two mixed numbers into decimals because they didn't really mix with the positive numbers. So we were just kind of comparing fractions there, and we didn't even need to turn the denominator to make it the same because 3/4 is clearly more than 1/3, as in more negative. All right, let's look at this set of numbers and see what it does for us. Let's do the negative ones over here. So we have negative 2 1/10 and negative 2. And the positive numbers are 2 and 1 repeating and 2 and 1/11. So if we add a number line, and this was 0. Negative 2 would be here. Negative 2 and 1/10 would be more negative than negative 2 because this is 0.0. All right, now looking at the positive numbers here, 2 and 1/11. Let's see what that is as a decimal. So 2 and 1/11 is an improper fraction. 22 plus 1 is 23/11. And that would be 23 divided by 11. 11 goes into 23 twice. Subtract, 3 take away 2 is 1. All right, adding the 0, bring down the 0. 11 goes into 10, 0 times. 11 times 0 is 0. Now pause, let's wait. Look at, that's 2.0 something right here. So this is clearly greater than this, because 2 and 1/11 is 2.0 something, and the other one is 2.1. So from least to greatest, we have negative 2 and 1/10, then negative 2, then 2 and 1/11, and then 2 and 1 repeating. Okay, one more, and this one's dealing with money. It's already all in decimals. Steve recorded these amounts in his checkbook. Negative $6.50, $7, negative $6.75, and $7.25. Order these from least to greatest. So the negative ones are here and here. $6.50 negative would be before negative $6.75. And then positive side, $7 is going to come before $7.25. So least to greatest would be negative $6.75, negative $6.50, $7, and $7.25. All right, the guided practice is complete. All right, let's try this independent practice on our own. We are doing 1, 2, 3, 4. So for 1, 2, 3, and 4, you're using the greater than, less than, or equal to sign. Remember, positive numbers are always greater than negative numbers. And turning numbers into decimals when they're mixed. So you'll want to turn that into a decimal. Look, those already, well, that one's positive, that one's negative. These are both negative, turn them both to a decimal. And these are both negative, turn them both into a decimal. And then for this section, we're doing number 5 and 6. And that's it. So don't worry about 7, 8, or 9. All right, remember on these two, you might need to turn them all into decimals. Go for it, then check your answers. All right, let's check our work on the independent practice. So for this first one, positive is always greater than negative. So 5/4 is greater. On the second one, you have both negative numbers. So 6 and 1/3, negative 6 and 1/3 is negative 19/3. When you divide 19 by 3, you get negative 6.3333, blah, blah, blah. You can stop because negative 6.33 is going to be greater than negative 6.37. Number 3 had 2 negative numbers. So negative 3/5, 3 divided by 5 gave you negative 6/10. So they were equal. And number 4 had 2 negative numbers. This one right here we turned into a decimal. So 9 and 2/7 is 65/7. 65 divided by 7. I just stopped right here because I didn't have to go any further. I could already tell that negative 9 and 2/10 was going to be greater than the negative 9.3. So once I got to that decimal place, I didn't need to worry about going any farther. For number 5, the first thing I looked at was the negative numbers. and I knew negative 2 3/4. I already know that 3/4 is 0.75. And so that would definitely be less than the negative 2 and 2 repeating. Then I looked at the two positive numbers. So that was 2 8/10, 3 1/8. And so 2 is definitely less than 3. So this is your order from least to greatest. For number 6, again, I started looking at negative. There was only one negative number, so that was the least. And then when it came to the positive numbers, 2/3 is 0.6 repeating. 4/5 is 0.8 or 8/10. So I could go ahead and order those. I knew that 0.65 was less than 0.66, which is less than 0.8. So I went and ordered from least to greatest. Time for the reflection. Okay, here's the Chapter 5, Lesson 5 reflection, comparing and ordering rational numbers. When comparing and ordering rational numbers, I remember that negative numbers are greater than or less than positive numbers. Use greater than, less than, or equal to. So you have these two numbers here, these two fractions. So look at positive and negative, positive and negative, positive and negative. When comparing and ordering decimals, I remember to look at place value, starting from the furthest number to the left or the right. So go ahead and look at that place value. These are both negative, both positive, and both positive. It's going to make a difference when they're negative or positive. When comparing and ordering fractions, I find the blank and then compare numerators. So when you're comparing fractions, what do you have to do first before you can look at the numerators? And then go ahead and do that with these. You're going to have to show your work of how you found that, well, you know, that thing right there. Number 4, when comparing and ordering a mix of fractions and decimals, I turn fractions into blank and then I compare. So what do you have when you have a mix? What do you need to turn them all into before you compare? Write that here and then show your work, order from least to greatest. And lesson 5 is done.